You're most welcome, dear viewers. This is Teacher Isaac, yet for another episode of Science. And before we begin, last time we looked at sources of light. We saw basically two sources of light. That was artificial sources of light and natural sources of light. With artificial sources, we said they are man-made. Then natural sources are God-made. That is by nature, okay? Now, we saw other two words which were new, that is luminous and non-luminous. The luminous objects are those ones which produce their own light. And we gave an example of the sun, etc. Then we have the non-luminous objects, those which cannot produce their own light. So today we want to concentrate on to the properties of light, okay? So it's called propagation or properties of light. Light has majorly two properties that you have to put into account. Number one is light travels in a straight line. Yes, we cannot see around the corners. You know that is impossible. You cannot see someone in the corner unless you stand in a straight line. In corners, you cannot see someone. So basically, that is what we are meaning here. Light cannot travel in corners. They will ask you one day a question, why are we unable to see around corners? And the reason will be this. That is because light travels in a straight line. So we have a practical something here where we have cardboards. Okay? You can join cardboards together. You can drill a hole in each of the cardboards, then put them in a line. They have to be coinciding with each other in a line, such that when light goes through it, you can always view the source of light. We have a candle here, a candle burning, okay? So it should be in a way that you can see the candle on the other side. So that simply means light travel in a straight line. If you alternate the order of the cardboards, that means you cannot see the source of light, that is the candle. Now in that case, it will mean that they are not in a straight line. They will only be in a straight line if you can only view the source of light, that is the candle. So that is one thing. We have another that you can try at your home, where you can get a bent pipe. Try to view through a bent pipe and see whether you can see your friend on the other side. It's impossible because the pipe reaches a certain point and bends. Therefore, light cannot travel through that to reach your friend the other side. So that is another way of testing that. Now we have another one which tests that light travels from a source to all directions. Yes, you have lighting, a light bulb at home. I'll give you an example, I'll draw it here, okay? But before that, we have a point here which really illustrates that light travels. Let's take an example that this is a source of light. Light is moving from the source to all directions, to all different directions. So if you light a candle at home, or a light bulb, if you switch it on, it will throw light everywhere, to everyone, okay? So that means it is traveling in all directions. Light travels in all directions. Let's look at this candle here, burning. In case a candle is burning, okay? This is a candle burning. You see that light is thrown in all directions. Light is thrown in all directions. Even if it is a light bulb, okay? You have a light bulb there. It will give light, okay, to all directions. So that one proves that light can travel in all directions. Light travels in all directions. So those are some of the major basic properties of light. Let's look at what we call a ray, okay? What is this one meaning? A ray of light. Ray of light. A ray of light. So you normally represent rays of light by just drawing lines, okay? A ray of light simply means the path taken by light. A ray is a path. A path taken by light. As simple as that. So that path taken by light is what we call a ray, and it can be denoted like this. This is how we just draw a ray of light. Simple as that. Now, we shall look at where rays come together, where rays spread from one direction to different directions. Those are just types of beams. So let's first of all find out what a beam is. Beam of light. A beam of light. What could be a beam of light? Let's first of all understand that. So a beam is always produced when light comes from one source, then it spreads, okay? So a beam is a group of light rays traveling in the same direction. A beam is a group of light rays. That means there are more than one ray. Light rays traveling in the same direction. A group of light rays traveling in the same direction, okay? So that one is what we call a beam. Have a group of rays facing in the same direction, traveling in the same direction. We call that a beam. One ray, I've told you, that is a path taken by light. Now here we have different paths, and those ones form what we call a group of light rays, which is termed as a beam. Let's look at the types of beams. Types of beams. Yes, there are three major types of beams. And we shall be able to illustrate them here. So one, we have a parallel beam. From your mathematics, you've talked about parallel lines. Parallel beam of light. So from definition of parallel, we know that parallel lines run towards the same direction and are equidistant from each other, meaning in between them they have the same distance, okay? If it is 2 meters apart, it has to be 2 meters apart until when they finish off. So let's look at what it looks like. We have them running parallel to each other. So when you look at the distance between these rays, it should be the same. So that's what forms something to be a parallel something. So we have, it can be 2 meters here and also 2 meters here. Okay? So that one qualifies to be parallel. You know how to draw parallel lines in mathematics. Now, a parallel beam behaves in the same way. Okay? Lines do not touch each other. So in your exams, if an examiner asks you to illustrate a parallel beam of light, please make sure that you draw these lines parallel to each other. They should never meet. They should not meet. They should be equidistant from each other. Okay? Now, number 2, we have a divergent beam of light. Divergent beam of light. Wow. A divergent beam of light. What does this one look like? To diverge, of course, simply means coming from one point and spread in different directions, okay? one point, then in different directions. In this case, we shall have light coming from a source, okay, and spreads out like that. So like car headlamps, they normally have that. A torch normally has that. So this is a divergent beam of light. We saw the first one, parallel, now divergent. Then let's look at 3, which is the opposite of divergent, and that one is convergent. Okay? Convergent beam of light. Now, converging simply is the opposite of divergent. To converge means to come from different directions, then you meet at a certain point. In other words, this is what will happen. Okay? We have rays of light coming to one point. Simply, that is a divergent beam of light. They are coming to one point. Okay? So, when an examiner asks you to draw any of these beams, I think right now you know what to do. Divergent, it has to come from one point and spread in all directions. I mean in different directions. Then this one comes from different directions and meets at one point. Okay? So those are the three categories that we can talk about. Let's look at effects of light in different materials. Effects of different materials on light. What do we mean by this statement? We want to investigate, we want to find out what is the effect of different materials on light. What do they do to light? What happens to light when it falls on such materials? It is what we want to see. So the first material will be material number 1, the transparent objects. Transparent objects. What are they anyway? What are transparent objects? Transparent objects are those objects which allow light to pass through them. They totally allow light to pass through them. I know you have glasses at home. You can see through a glass. But there are those glasses which you can't see through, and we shall see. Even in your cars, you have some glasses where you can see through, others you can't see through. So we want to look at transparent objects. Okay? These are objects. These are objects which allow light, allow all light to pass through them. Okay, they allow light to pass through them. Now, such objects are called transparent objects. And we know examples, like I've already told you. We have clear glass. Okay? Clear glass. Think of another transparent material that you know. Clear glass allows whole light to pass through it. You can see through a glass, okay? Not only a glass of water, but also the glass we find in windows, in some cars, they are transparent. We have another example, that is clear water. It has to be clear. Clear water. Why do you say clear water? because some water is not clear. Like muddy water, you can't see through. Okay? You cannot see through muddy water. That's why we say clear water. You have to have clear water in order to see through. So if someone dives into a swimming pool which has clear water, I know you might tell me that the swimming pool is blue, but that is just paint down there in the swimming pool, which is sent to your eyes, reflected to your eyes. Then you think that the swimming pool is blue, but the swimming pool has clear water. Now if someone is swimming, you can always see that person. I think most of you have seen this. Okay? You can look at that person and see that, oh, the person is there. Or even those who watch Olympics, you can watch people swimming. Okay? So when they dive, you can always see them. How do they tell that this is number 1, this is number 2, this is number 3? By using their own eyes, because they are swimming in clear water. We have the last as air. As I'm looking at the camera right now, between me and the camera there is air. And I can see the camera can also see me. That is possible because air is transparent. We can see through air, okay? Let's look at another type of objects, and that is translucent objects. Translucent objects. Let's see what they are. Translucent objects is number 2, that was number 1. Translucent. We have translucent objects. Now, there are those objects which allow little light to pass through them. Those objects which allow little light to pass through them are what we call translucent objects. They don't allow all the light to pass through them. Okay? An example, you know some of the clothes that we wear, they are translucent. At least you can see that, oh, that person is dark. Okay? Then we have other materials, like when you get a paper and smear maybe grease or Vaseline, that paper becomes translucent. You can also smear cooking oil, okay? So that one is translucent. Let's define translucent. These are objects which allow little light to pass through them. Little light to pass through them. Yes, you've seen even some glasses. Some glasses normally allow some light to pass through them. So, when you look at a certain car, you see it is tinted. We call them tinted glasses. They are not totally dark, but a bit dark. Those are what we call translucent materials, okay? Some clothes, if you look at your bed sheets, some bed sheets are translucent. They can allow little light to pass through them. Okay, I've given you an example of paper. Let's look at examples. E.g., we have frosted glass, or you call it tinted glass. Frosted glass can also be called tinted. This one is common in vehicles. These days, even in houses, the windows of houses, we have such glasses. Okay? All right. We have another one that is colored glass. Some glasses which are colored. For example, the ones you put on, the specs. Some look as if they are blue, bluish. Some colors, okay? Colored glasses. Okay? Those ones allow little light. We have oiled paper, even if you call it greased. Oiled paper. Oiled paper allows little light to pass through. Then thin cloth. You know those cloths that are thin. Thin cloths. Okay? Now those ones allow some light to pass through. I gave you an example of a bed sheet. A handkerchief is also thin. Okay? Those ones can allow little light to pass through them. Now, we have what we call tracing paper. Tracing paper. Tracing paper, those who are artisans or people who are artists normally use the tracing paper to see objects underneath or what they are trying to trace, okay? All right. Effects of translucent objects on light. Effects of translucent objects on light. We have already stated that these allow little light to pass through. They allow little light to pass through, so that is one of the effects. They diffuse light, they condense it in other words. They allow little light to pass through. Okay? They also diffuse light. So the light intensity is diffused. Okay? They can help to diffuse light. As simple as that. Those are translucent materials. They allow little light to pass through them. And we have given examples of such materials that allow little light to pass through them. They are up there. All right, let's look at another kind of category of material, of objects, and that is the last one on such materials. Okay? We have the opaque. That is number 3. Opaque objects. Opaque objects. The word opaque simply means such an object blocks light. It does not allow light to pass through it. For example, myself, I send a shadow backwards. It means I'm opaque. A human being is opaque. A wall is opaque. Many things are opaque. So basically, metals are opaque. You can't see through a metal. Okay? Those are opaque objects. Let's define them. These are objects or materials which do not allow light to pass through. They do not allow light to pass through. Basically, those are opaque objects. Now, what are some of the examples of such materials? They never allow light to pass through them. Okay? I've told you we have the wall. Examples. We have a wall. When you look at a wall, you can't see behind a wall. You cannot. Hard paper. We have hard paper. Such, you cannot see behind them. Okay? We have materials like wood. You cannot see behind wood. It is an opaque object. It is an opaque objects. We have the human body. Human body. That one does not. We have metals. Metals do not allow light to pass through them. So basically, those are some of the examples of opaque objects. So, in a nutshell, we've seen beams of light. We talked of the parallel beam of light. We looked at the divergent beam of light. We also looked at the convergent beam of light. We said parallel run equidistant to each other. Then divergent beam of light travels from one point and spreads in different directions. Then convergent comes to one point from different directions. We've seen the effects of light, materials on light, different materials. That is transparent, they allow light to pass through them, all light to pass through them. Then translucent, those ones allow little light to pass through them. And lastly, we have seen the opaque objects. Opaque objects do not allow light to pass through them. I'll give an example of myself. When you flash light into my body, you will not see through me. Not even what is inside me. Maybe if you use an X-ray. Of course, still that is light which helps us to see that. But without that, you cannot see my heart. You can't see my intestine. Why? Okay? So you are opaque as well. Materials like the wall, opaque. You cannot see through walls. Now, opaque objects will bring us to what we call shadows. And I'll leave introducing that shadows. Those that are formed when light is obstructed by an opaque object. So whenever we mention an opaque object, just know that that object does not allow any light to pass through it. Okay? With those few words and content, I would love to stop here and wish you all the best. Until we meet again in the next lesson, don't forget to subscribe to our YouTube channels so that you can always receive or get what we upload. Thank you. You have been good viewers. Till we meet again. Bye-bye.